Hi everyone, this is the first of the weekly discussion videos that we'll be posting. We'll be posting one for each week, which means one for each PA. And the goal of these videos is for us to either demo tools or demo some concepts related to the current PA that's out to help you guys out. Because most of what you're grappling with this week is setting up your local environments, and because we already have some instructions for getting up and running with these, this video will probably be relatively short. I plan on briefly going over some useful information about course logistics and then showing what it looks like to start up some of the tools like Azure and VSCode with Docker. And then lastly, I'll move this. So I want to talk about some course logistics and then show what it looks like to start up Azure, show what it looks like to start up these two things. I'll be showing it on Linux virtual machine. And then I'm going to show some commands that you can use to install things like C++, G++, make, GDB, and Valgrind locally if you happen to have a Linux virtual machine, or if your computer is dual booted. Specifically, the commands will be for Ubuntu. But yeah, so I'll be showing those at the end. So if you are in that situation, those will be helpful for you, hopefully. Yeah, so that's the game plan. So maybe before we get into the tools, we can discuss some of the logistics things that I just wanted to make a note of, because I think it'd be good to do that. So, okay. So let's see. Okay, so yeah, the FAQ post. So probably a lot of you have seen it. Let me toggle over to it. So probably a lot of you have seen this Q&A post. It's pinned at the top. It's number 58 on Piazza. It's grown quite large. I don't think we anticipated it to be quite large. But essentially what it is it started as a bunch of Q&A from discussion earlier in the week, because you guys had a lot of great questions, and we have just been adding to it. And these are kind of like your most common questions from the students so far. And if you happen to have a question about course logistics, if it's not explicitly answered on the website, which it likely is, if it's not, then this is a good place to check. So you can, if you have a question, it's good to just like peruse this. You can even control F. So like, for example, if I wanted to know if there's anything about the reading quizzes in here, I could just control F and look and just see if my question's answered in here. Maybe it is, then it saves you time. If not, then then it's not, but it's a good thing to check. Okay, yeah, so just wanted to point that out. Some highlights from that. Okay, I can't zoom. Some highlights from that are good to talk about, just so everybody knows, in case you haven't seen that post. So one common question, just wanted to be really explicit that it doesn't matter how you're doing your PAs locally or doing your work locally. Whatever works for you, and that's great. We want it to be whatever is best for you. As long as whatever you submit to Gradescope runs on the autograder, you're good. So feel free to use any of the tools that we suggested, or just install things locally yourself, or any other tool that you know, that's fine. So that's a big thing. Another big question that we've been getting is the logistics of submitting to Gradescope. A lot of people have been asking about wanting to be able to submit essentially like their GitHub repository as their submission instead of dragging and dropping files. And as it stands right now, it looks like we have some issues with that being a viable option, because all of your repositories belong to a private GitHub classroom organization. And so there's some like sharing issues that we're running into. And so we don't know if we can find a workaround for that. So even though Gradescope does allow for that functionality, because we have the classroom, it's that's private, and the repositories are part of that organization, it's a little bit hairy. So I don't think that's an option right now. If it becomes an option, we'll let you know. But one thing you can do that should work is you can check out, if you are not that familiar with Git, maybe you are, but if you're not that familiar with Git, you can check out the Piazza Post 42. Let's see, Git Basics. So, and you can check out this section right here called pushing a project to your own GitHub. What you can do is, if you want that functionality of being able to submit a repository from Git to AutoGrader instead of dragging and dropping files, then I would imagine that you can push your local code, so you have your remote repository that's part of our classroom, and then you cloned your own local one, and you can create a new remote that's like private, just to your account, like only you can see it, and you can push your code there. And then I would imagine that Gradescope, like you can submit that repository to Gradescope. So that's worth a shot. I think that should work. But anyway, important to know. Okay. All right, what else is on here? Quick thing about the waitlist is just that if you are on the waitlist, unfortunately, we don't have any information as far as like, what are the chances that you'll get off the waitlist, and we don't have any power to do anything about it. It's out of our hands. So we recommend contacting maybe an academic advisor about it if you're really in a bind or if you want more information. And then, not related to course logistics, so I guess this is pivoting a little bit, but so I'm gonna pivot a little bit to what I'm highlighting here, which has to do with the current PA. So I guess it's an FAQ and a PA thing. There have been a good number of posts where I've seen the commands that you're using to compile are the ones from the instructions, which makes sense. You follow the instructions, right? So I'm just pulling up PA1 starter. So for example, like this command, a lot of people are using. It makes sense, it's in the instructions and everything. But one nuance that people are running into is that sometimes you need to add this standard C++11 flag to provide C++11 support. Some people are getting, if you get an error that says something, if you get either like an error or warning that says something regarding C++11, it might be that you need to include this flag. But yeah, so you might need to include this flag. But aside from that, what is probably like the best and like easiest thing to do for this assignment is just to use make. You don't have to type out a full command. So like, for example, you don't have to type out this whole thing to make hello world. You can just type make hello world, and that's it. So where do I have that? You can just type this and enter this, and it'll do the it'll do this command with that extra standard C++11 flag that you might need in some situations. So I think the best bet is just to use the make file. So when you're making hello world, you can do this. When you're making the swap test, you can do this, and so forth for the other components. I think that will be a lot smoother and a lot easier and less typing and all that business. Yeah, so use the make commands. I think it'll be good. And then the other thing is, if you are interested in running GDB, which is always a good idea if you run into errors, many of you may know that you need to have the -G flag in the command. So like right here, this -G flag is not in our make file. So if I go to the make file, let's see, oh, here we go, the make file. If you're not familiar with make files, totally okay, but some things to highlight is just like at the top, we have these flags that we're passing to the compilation, to the command for compiling, right? So all of these flags will be included. Anytime you see CXX flags, right? So if you notice in all of these, you don't see like the -G flag anywhere. So anytime you do make whatever, make swap tests, make hello world, any of those, the -G is not being included. So if you want to have the debugging info, if you want to have the functionality to use GDB, and you need to use this this -G flag, then you do need to like write out this or type out this entire command, because make hello world will not suffice because it doesn't have that G flag. So that's the one thing. And then the other thing too is, at least I would recommend that, like, so in our make file, typically we'll use this -03 flag. If you've never seen that before, it the O is for optimization, and the number describes like how much optimization the compiler is going to do. The lower the number, the less optimizations. The higher number, the more optimizations. What that means is if you do -03, then a lot of your code might get optimized out. And so if you go to debug and you want to trace your code, a lot of your code could have been optimized out, and it's not easy to navigate and trace. And you might try to print a variable, but the variable, you can't print it because it got optimized away. So what you can do instead is use a dash. So this is like the letter O, not a 0, letter O, and then 0. The 0 is describing like the lowest optimization level. So it should generate machine code that's very close to, like, it should not optimize away a lot of your code, and so it should make debugging in GDB a nicer experience than if you had O3. Okay, yeah, so that's important. Okay, cool. So I think that's everything I wanted to discuss about FAQs. Okay, so another thing that I wanted to do was point you guys to resources that I feel will be helpful when working on this PA. If you are new to C++, or if you're not new to C++, but you need a refresher on C++, then I definitely recommend checking out these two resources. So the first one is the week 1 YouTube C++ videos. So you can go to the course website, and then you can click on schedule. And this is where we have links for lots of things. But under week 1, there is this group of videos that has C++ in the title, and this is what I'm referring to. So depending on what you need to refresh on or what you need to learn from scratch, you can watch the relevant video. These are YouTube links, so if you don't have access to YouTube, you can try these links instead. So I think those would be pretty good. And then also Stepic Chapter 1.4, I think would be really great as well to do. I think both. And then beyond that, if you are just looking for resources that are useful for the specific components of the PA beyond just C++ knowledge, I've listed what I think might be helpful. There are definitely other videos and resources in the class that are helpful. These are just a couple suggestions. So for like Hello World CPP, I listed Lecture 2 Video 8 Input Output. So how you can find what I'm talking about is, so I said Lecture 2 Video 8. I can go to the lecture number 2 Video 8 Input Output, and I can watch that video. So yeah, so you can check out these recommendations if you want, as well as other resources in the course, but these are what I would recommend at least at base level. Okay, so now we're going to talk about Azure as an option for something that you can use and work in to complete the PAs. To be really explicit, right here, I'm in the demo project repository that was linked at the end of PA0. If I scroll down to the README, I can see these options listed for me, so I can use any of these tools. I can install them and work in them to complete the PAs. And below, I see these wonderful instructions for how to install them and get them up and running and things. And just to be really clear, even though we list options here, you are not required to use any one of these options in particular. You can use any setup you want. We just need your Gradescope submission. However you get that to us, that's fine. But out of these 5, really only options 2 through 4 are 100% surefire viable options right now for completing the PAs going forward, including this current PA, for or at least in this list of 5 things. There are other ways to complete the PA if you know of other tools and things. But for number 5, this replit, it was just meant for PA0. And then as far as the lab machines go, it seems like as of now, some of our tutors and some of the students have said, at least like anecdotally, we're learning that some people have been able to SSH into the lab machines using their UCSD Active Directory name, so like your UCSD username. You can go ahead and try that if you want. We don't know what the situation is with that right now. We're actually in correspondence with ITS right now, trying to get accounts, like CS100 accounts set up for everybody in the course right now with all of the dependencies installed. So things like Valgrind, GDB, C++, like all of that business. We're in correspondence with them right now, trying to get that set up. But while we're doing that, we've heard that some people have been able to log into the lab machine. So you can go ahead and try SSHing using your UCSD username if you have done if you've done SSHing in the past to those, and see if it works. You can, edit the code and then do something like make hello world and see if it succeeds, and then that G++ and make are installed on that server, and then you can try using Valgrind and try using GDB to see if it's even installed on those servers. We're not sure ourselves. So this is kind of like an option with an asterisk, I guess. So it's like, you can try, maybe it has the things you need there. We're not sure. We're still talking to ITS, but definitely 2, 3, and 4 are options you can use for going forward. Of these two, between the Devcontainer and the Azure Cloud Terminal, I would say that Azure was definitely infinitely easier to set up than Docker and VSCode for Devcontainer. But it does seem that you're a bit more limited with Azure. So like, for example, I was not able to get Valgrind to work in Azure, and many other students weren't able to either. Not that you need Valgrind to work in order to submit the PA, but if you don't have Valgrind, then you don't have that tool at your disposal to help you debug. So that's just something to keep in mind. So it's a little more limiting, but this was just so painless to set up. It took me literally 5 minutes. So it's nice to know. It's a good thing to have if you can't get other things working. So there's that. And I also just want to emphasize again that you are not required to use any one specific tool. You can use whatever you want. But right now we're going to talk about Azure. So let's take a look at Azure. So I just followed the instructions as they were here. I created an Azure account, and then I did these commands, and then I clicked on this button, and then I did these commands exactly. So if I go to my Azure account that I created, this is what my, I guess my page looks like. And the instructions right here say to go to this button. And so that button lives up here. So I can just click on that button, and then it starts things for me. We'll just wait. Okay, that was pretty fast. And I've already, before this video, I've already gone ahead and done these steps essentially. So I already have like Cloud Drive, and I have my repository cloned and everything. But just to be extra clear, in this step, you don't want to actually, like for working on PA1, you don't want to be working with demo projects. And make sure in this step you do git clone your PA1 repository. My PA1 repository has a slightly different name than yours will have. But yeah, so just make sure you don't misstep there. But anyway, okay, so I've already carried out those instructions on there, so we can just see what I have. You can see that I can just use Unix commands in here, which is really nice. This is really lightweight. And so PA1 starter, that's my repository. Yours is probably named something like PA1 dash your GitHub username. So yours will look slightly different. But so we can go into it. Oops, just kidding. We can go into it, and then we can see that all the files are there. That's awesome. And if we want to edit one of those, there is an interface for that too. So what you can do, and this is again in the instructions, but you can just do code and a dot, and then it should open. Okay, it's a little squish. We'll just stretch it out a little bit. So, or a lot of bit. Maybe a lot. Oh, okay, I guess that's the most I can do. Okay, so yeah, so it's kind of nice because down here in the bottom area you have like your command line, and then over here you have all the files, and then in here you have this is editable. So if I wanted to, for example, start working on Hello World, I can double click it, or maybe it was a single click, I don't know. One of the two. I clicked it, and the starter code popped up, which is great. And then I can just, go in here and start editing right away. And I can save and I can run and all that business. So if I just did something really simple like okay, cool, great message. And then if I do make hello world, you can also see the command that it used to compile. And you can see that it includes that C++11 flag that I was saying. Okay, so we just made it, so then we can just run it like this, and there we go. Cool. My code ran. So yeah, this is the basics of Azure. There's, at least from what I can tell, there's not much more to it. Yeah, so that's how Azure works. Pretty nice. I think it's a little bit more limited in capabilities, but it took like maybe five minutes to figure out. So that's pretty great. Okay, cool. So the next one that we'll do is Docker with VSCode. Okay, so now we're going to talk about the Devcontainer option, which uses VSCode and Docker together. And once you have things set up, you can see that VSCode's layout of its interface is pretty similar to the layout of Azure, as well as other IDEs that I'm sure you've seen. So you have your source code files over here, you can edit them up here, and then the command line is down at the bottom. You all are probably very familiar with this page by now, but just to be explicit again, I'm at the demo project repository that's linked at the end of PA0, and I can scroll down to this is the README. I can scroll down to the section called Getting Started with the Devcontainer, and it has the instructions for installing VS Code and Docker and getting them to work together so that I can work on my PA with them. While you're following these instructions, if you are a Windows user, definitely make sure that you heed the notes with these beautiful yellow warning signs. But beyond that, make sure you also just heed the fine print. If you pay close attention and you read carefully and see these details, it could really be the difference between a big long headache and a smooth install experience. So I guess that really goes for everyone, not just Windows users. But these are the instructions. These are the exact instructions that I followed to set up, and I didn't have any issues. Then again, I set up on a Linux machine, so maybe I had an easier time. But if you can get VS Code and Docker set up and working for you, it'll be a big payoff. It's a pretty powerful combination. So I'm going to show you what it looks like to start it up and work on it in my virtual machine. This is my Ubuntu virtual machine. Regardless of what machine you have, one thing that you want to make sure you do is make sure that Docker is started up before you start up VS Code. So for me on Ubuntu, that means running this command. This command will start Docker for me. On a different machine, it might be a wildly different command. It might be through a user interface. It might be really similar. For example, I think if you have a Debian machine, it might be exactly the same, or it might be really similar. But so you want to make sure that it's running, or you want to make sure you start it. And then I also, this second command that I entered ensures that, or it's like a sanity check for me. It will print out the status of Docker, whether it's inactive or active. And since it says that it's active, that means it's on. I'm good to go. And so even if you don't have Ubuntu and you're working on a different machine, you should be able to just, Google whatever you need to check that things are running. It might look way different than what you're seeing here, but I mean, I googled these. I was like, how do I make sure that it's on? And there were a bunch of options. This is just one of them. So just make sure that you start up Docker and make sure that you make sure it's started up. So since I'm good to go, I'm gonna go ahead and start up VS Code. Okay, cool. VS Code is here. This is just the welcome page. What we want to do is open our repository. So we want to go over to the left. You see this toolbar with a few options, and we want the one at the top that says Explorer. That'll let us explore our files and pick folder. So I'm going to go ahead and click on that, and then I'm going to click on Open Folder. And then I'm going to click on my PA1 local repository. Again, as I said with the Azure demo, note that the name of my repository is different from yours. Yours is probably named PA1 dash and then whatever your GitHub username is. So unless your GitHub username happens to be starter with a capital S, then we have a different folder name. So just make sure, so just click on your PA1 starter repository, whatever it's called. Okay, so I'm gonna select it, I'm gonna do okay. I open it. Cool. So over here, I can see PA1 starter and all the files in it. It loaded, and I see this message on the bottom right pop up saying, hey, I can tell that this contains a dev container. Do you want to open it in the container? I do, so I'll click reopen in container. And that's just following the instructions that were provided from the demo project. So I think it's this big picture is what I just clicked on. It's pretty high res. Wow. Okay, so back here. Okay, so it's thinking, it's loading. Something else that's interesting to point out, if you back up the video, maybe you can see, but right here where I'm hovering over with the mouse, now it's called something like CSE 100 Devcontainer, whereas before I put it in the container, it was just the name of the repository, like it was PA1 starter. So it's kind of nice for peace of mind that I can see right here that it's in the container successfully. So that's pretty cool. Oh yeah, now you can see the whole thing when I don't hover over it. Okay, cool. So now I'm in the container. I have all my files here, and I can edit them, right? So I can do the same thing that I did with the Azure. Right. So I can edit in here, and then I just did Control S to save. And then down here in the terminal, and you want to make sure that over here on the right that it's bash. You may or may not have other options here, but just make sure that it's bash. So over here, I can do ls, and I have all my files, great. And so I should be able to just make hello world like I did with Azure. And I can see the command for compiling again, which is cool. I mean, that always happens with make, but it's just nice to know, behind the scenes how we're compiling your code. So, and then I can run it, and it prints my message. Wow. So that works. So that's generally just how you can like start up VS Code and in the container, and then open up your repository, open up a file, edit it, run it, stuff like that. You can also, down in here, you can in the terminal, you can run GDB, you can do all that stuff, like provided that it should be installed in the container. Yeah, so you should so if I do like GDB version. It looks like it exists. Okay, so yeah, so it exists. And if I do grind version, it exists. Cool. So it's there. It's in the container. So you can go ahead and just use those, which is cool. Okay, so what else can we do with within the dev container? One thing that we can do that's pretty cool, I'll demonstrate in a second, but before I show it to you, I just want to point out that I've added some code to hello world.cpp. Note that this code has nothing to do with what you actually have to do for the assignment. I just wrote this code so that I could demonstrate the debugging interface for you in VSCode. But before we do that, we have to make a small edit. So over here in my source code, I want to open up tasks.json. And within here, this right here specifies the command that will be run when we run our code in debugging mode within VSCode. And right here, we want to change this -03 to -00 and save it. And what this will do is it lowers the optimization level. So the O is for optimization, and then the 0 specifies that it's at the lowest optimization level. And we'll need to do that because if you leave it as -03 and then go to debug with GDB, a lot of your code might be optimized away, and then your experience in GDB might not be great because variables might not be there anymore and breakpoints don't work and stuff like that. So just make sure that you update this to -00 from -03 and then save. Okay, so now I should be good. Okay, so here's my code. I just implemented a main that creates an array and then calls a function that computes the sum of the elements and returns that sum and prints it. Pretty simple. So if I want to debug this, I can do a few cool things. One thing I can do is set breakpoints. So over here, if next to the line numbers, you see like this red dot, I can click on a line to set a breakpoint visually instead of doing it within GDB. So I can do, maybe I want one there, maybe I want one there, no idea, I'm just making this up. Let's do one here, cool. So each of these red dots is a breakpoint in my program. So if I were to run in debugging mode, it will know about these breakpoints. So let's run in debugging mode and see what happens. For me, I'm just gonna push F5. I believe it should be the same for you regardless of your machine, but it will run the code in debugging mode. So I'm gonna hit F5. It's going. You can see that -0, the O0 flag. Okay, and what it did is before I was in the terminal, and just now what it did is it switched me over to debug console. So it should move you over to debug console. So now a couple things have been added. I see this yellow line highlighting my first breakpoint. So it compiled and ran my code and went forward until it hit the first breakpoint, and then it highlighted it for me, and it tells me this is the next line to be executed. And also this like, it looks like a home plate. This pentagon is also indicating it. But over here, you can see local variables, which is pretty nice. You can see their values. So right now, these are all garbage values. You know, X and Y, I guess, happen to get 0. Z happened to get this address, and yeah, and then the value. Let's see, value that. Yeah, the value at that address is 1, I guess. So these are all just like starting garbage values. They don't mean anything. But as we step through the program, these will change, which is pretty cool. And then down here, you also have the call stack. So right now, we only have main, which makes sense, right? Because we're right here at line 20. So if I wanted to step through my program, I can do so using these buttons up here. So it looks like I have, I think this is called continue. Oh, the hover text isn't showing, but this should show continue, and then this shows, maybe if I click, oh no, there we go. Oh, okay, yeah. So this is continue, and then This is step over, right? You can hover over them to see what they do. If you need to restart, you can click this, and if you want to go back to the terminal and exit debugging mode, you can click this. But instead of entering like GDB commands, you can use these arrows. So for example, if I'm at this line right here and I want to step just one line forward to this next one, I can click this one called step over. So I click it, and then you can see that this yellowish greenish line that's highlighting the line has advanced down one. And in addition to that, it's also highlighting this 7 right here, indicating to me that this just happened, like this update just happened. So X just got updated to 7, which makes sense because we just ran line 20. So that's cool. So if I, step forward again, then I'll see Y updated. But instead of doing that, what I'm going to do is click continue to show you that if I click continue, it will move forward until the next breakpoint. So if I click continue, now it's advanced to the next breakpoint. And up here I can see that X is still 7 and Y got updated to 5 at some point, which is what I expect. That's cool. And then also now that I've assigned Z to point to, now that I've assigned Z to point to X and X stores 7, this is saying that ZD referenced is 7, which is also what I expect. So that's cool. If I were to step forward 1, then we should expect this value to change to whatever Y times 2 is. So Y is 5. So we should expect that if I step forward, that Z or star Z should change to 10. So let's do that. And it did. Cool. So it changed to 10. And also, X changed to 10, which makes sense, right? Because Z points to X. So both of those got updated with that. So you can use these to step forward 1 step or to continue to the next breakpoint. So like if I did this, I go to here, then I can do this, and it'll go into this function. I can step through it and watch as the variables change. One thing that's cool is that now that I'm in get sum array or get array sum, that's the name of my function. Now that I'm in here, over here, the locals that it's showing me are the locals for the function that I'm in. So it tells me that I is 0, and it tells me that the sum is currently 10 and all of that business. I can also, if I step forward, then we'll see I should increment, and sum should also get bigger too as we add. So if I click forward a couple times and we watch this change over here, so the I just changed. If I do it again, the sum just changed, right? It added the 5, which is the second element, and click forward and just watch the variables evolve. Okay, so and when I get to this line, return sum, if I step forward, I believe that down here with the call stack, I think this should disappear and it would just leave this. But before I do that real quick, I just want to show you, let's say that, I'm in here and I'm like, wait, I forget, like, what are the values of this array that I passed in? I don't remember. Over here, it's just showing me the values of the local variables for get array sum, but I want to know what ARR was from main. I don't remember. What I can do is I can click on main, I think. Yeah, so I clicked on main, and when I did that, it updated the locals that are listed here, and it's showing me the local variables from main, because that's what I clicked on. So I can look and see, like, oh yeah, the first element was 10, the second's 5, the third's 10. Okay, cool. And I can click on this, I can go back, and now the locals that it's showing are the locals for this function. So that's pretty cool. So I'll just continue. I think that, yeah, that's the end of the program. So you can use this interface to debug your program visually, which is pretty cool, and you can see the variables updated as you step through it. This part is kind of, I think MATLAB does something similar. If you've used MATLAB before, you can see the variable values for things as you go through. So that's really nice. Yeah, so just make sure that if you want to use this functionality, that you update that flag in tasks.json and then use the interface at the top to step through. In my experience, if I tried using GDB commands down here, the interface didn't update properly. So you have to use this exec thing and then like a GDB command after to use GDB commands down here. But if I interacted with this debugging interface by doing the GDB commands down here, the yellow line like didn't advance, and these variable values were garbage, and it didn't work. So you want to, if you want to use this functionality, then you want to use those buttons that were at the top. If not, though, you can always use GDB like you normally do, and you can, in the terminal, you can use GDB like you normally do. So you also have that option, so that's pretty cool. What else? I think there's one other thing. Oh, right. So there's one other thing that I found really useful, which is the command palette. So this is mentioned in these instructions. Let's see where I can find it. Oh, it's right here. So in these instructions, it mentions the command palette and how to open it. For me, I use Control-Shift-P. I believe it should be the same for Windows, and then if you're on a Mac, you want to use this. So if I go back to my virtual machine and I do Control-Shift-P, then a bunch of options show up. And what this is it's kind of like all of the actions that you could possibly take in VS Code. It's pretty cool. You can even, this is kind of like a search bar, so you can, if you wanted to look for commands that have the word remote in it, it'll do a search for you, which is cool if you're looking for something specific. There's a lot of things in here. We're not going to use even like a small fraction of these, but it's really nice. Also, it's kind of cool. There's like this bar that appears right here. So after you've done some commands and messed around with them, this bar will appear and kind of group your most recently used commands up here. So if you find yourself using one over and over, it'll keep it at the top for you, which is pretty nice. Like I don't know what any of these are and I haven't used them. But one that I found particularly useful was close remote connection, and it will close out my container. So if I go, so actually just to show you, so we've been, when I did the debugging, I think it changed. So over here before, when we were working in the container, we were here, and then when I hit F5, I think it took me here. So if I want to go back to that spot that showed me all these files, I can do that. But anyway, if I go to the command palette, I can do remote close, remote connection. I click on it, and then it'll close everything out for me. And yep, so it closed it out for me, so now it's gone. So that's a way that you can close out your code. But that command palette seems really useful. I'm sure that there's other useful commands in there that I'm not aware of, and you can tinker with in Google and see what are useful for you. But yeah, I think that's all I have for the Devcontainer. Okay, so the last thing, which is pretty quick, is wanted to show some commands that are relevant to those of you who happen to be working in Linux machines or Linux virtual machines. And if you would prefer, instead of installing one of the other environments that we've discussed and recommended, if you just wanted to install any dependencies for the class outside of those environments, just like, work in the terminal and like in a text editor, then you can use these commands to get the essentials. These, like I said, these work for Ubuntu, and I believe they will work for Debian as well. If you're using a different Linux distro, they might be very different. They might be slightly different. I'm not sure because I'm only familiar with installing for Ubuntu. But for Ubuntu, at least, this command will install GCC, G++, and make, and this one will install GDB, and this one will install Valgrind. This apt-get that you keep seeing is the package manager for Ubuntu, so it allows us to install packages. Make sure that if you want to install these things, that you first run this command, sudo apt-get update, before running these three, but it should be a fairly painless process to install these if you already have a Linux machine at your disposal. So yeah, you can go ahead and run these. Hopefully being able to see the tools started, launched, and you know, in a working form, gave you some peace of mind, just to see what it looks like and how to click around and how to run something, just the basics. So hopefully that helps and gives you some peace of mind. Maybe helps inform you more on what your personal decision will be for how you want to work on PAs for the class. The next thing that I'm going to demo is a couple different ways that you can use to submit your PAs to Gradescope. In this example that I'm going to do, I've implemented what I think is the correct solution for Hello World's main, and I'm going to submit my files to Gradescope to see how it does. So I'm going to pull up Gradescope. Don't mind these results. This is from a previous submission, so just pretend like these results aren't here. I'm going to click this button in the bottom right, and this window pops up, and it says that I can drag and drop, I can include a zip, I can browse, I can do a couple things. So first I'm going to show what I think is the easiest way to do it. So I'm going to click on this box, and this already navigated to my repository for me, but you may need to click on here to navigate to the proper folder. But I want to multi-select all of the 4 files that need to be submitted for PA1, which is fastsaga.cpp, helloworld.cpp, q.cpp, and swap.cpp. The way that I did it, at least on my machine, is I held down Control and then left-clicked on all those. It might be slightly different on your machine. It might be like Command or Shift or Alt or something, but you should be able to multi-select. And then I'm going to click Open, and I see my 4 files are there, which is good. Then I'll click Upload, and then the autograder will take a second, but okay, great, yeah. So it didn't take too long. So we can see that I passed all the tests for Hello World, and I got full credit for it. And it makes sense that I got zeros on these because I haven't implemented these yet. So this means I got full credit on Hello World. So that's pretty cool. Okay, let's look at another way to submit that's really similar. Let's do resubmit, and this time let's use the drag and drop way. So I'm going to click on my file explorer. I'm going to do the same thing. I'm going to multi-select. So I'm going to click on this one, and then I'm holding down Control, and I'm clicking on this, and clicking on this one. Right, those are the 4 files. So I multi-selected them. Now my finger is not on Control, and I left-clicked, and I'm dragging this over into the box and then dropping. I let go of the click, and you can see that it let me put all 4 of those in there. They're all there. That's good. So then I'll click Upload, and I should see the same results. And it'll just take a second. Cool. Same thing. Great. So those are 2 ways that you can submit that way. Another thing that you can do, if you feel so inclined, is you can submit a zip. So for example, I'm going to multi-select again. So I'm multi-selecting these, this one and this one, right? Those are the 4. I'm right-clicking, and then on my computer, I believe it's compress. It might be a different command on your computer to send to a zip. So I'm clicking compress, and then I'm going to call it, I'm going to call it PA1 starter.zip. I'll do create. Okay, cool. So I just generated this zip file. Again, the process might be different for you, but here's my zip, and it has if I click on it, I can see that it has my 4 folders, or my 4 CPP files in it. So I have this, and I can just submit this zip. So if I do resubmit, I can click here, click the zip, click open, and it'll extract its contents for me, which is good. So just click upload, and it'll be good. Notice that in all these situations, when I submitted, or when I either drag and drop my files, or however I selected my files, all you saw there were the 4 files. They weren't in any nested folder, right? They weren't like the file paths. So actually I can show you here. If I go to code, I can see my 4 file names, right? They're not named PA1 starter / swap.ppp or PA1 starter / q.cpp. So in other words, they're just the 4 files. They're not within a folder. You want to make sure you don't submit like a folder with them inside it. Otherwise, you're going to get an error on this interface. It'll tell you that it can't find the files. So any of those will work. Okay, so the last method that I'm going to show you is how to submit to Gradescope using a GitHub repository. So as we mentioned earlier in the video and on Piazza and a few other places, it doesn't seem like it's possible to submit your repository that's within the GitHub classroom because it's a private classroom and there's some access issues. So what you instead need to do is create your own remote. And so I'm just going to go through that process if you haven't created a remote before. And what that means is, in case you don't have a lot of experience with Git, the repository that is in the GitHub classroom is we say that it's a remote repository, right? It lives on GitHub's servers, and then when you cloned or downloaded it, now you have what we call a local repository. So you have that repository locally on your computer. Now what we want to do is create another remote repository that's going to have your code, but it's going to live just on like within your account. It's not going to be within our GitHub classroom. So I'm going to go through doing that. So actually that's a little distracting. So okay, so here I have the terminal. And I've gone into my repository. I just did ls to show the files. And where I'm at right now is I have implemented hello world. And what I want to do is commit my changes and push well, first I want to commit my changes, and then we're going to create a new remote and push the changes to the remote. And then we're going to, on Gradescope, submit using a branch from that remote repository. So that was a lot of words and a lot of steps. So let's go through them. Right now in my repository, I can do git status to see what the status of my repository is. And you can see that it shows this file in red. And what that means is it's saying, hey, we see that you've modified hello world since the last commit. If you want to stage these changes, you need to add them. So we're going to do git add, and then you can either do git add hello world.cpp, and that will stage the modifications that you've made, or you can just do git add dot, and that will stage all of the changes within the current directory. So if I had made changes to multiple files and I wanted to add all of those changes, then I could just do git add dot as a shortcut. So I'm just going to do that. So now if I do git status, I can see now it's showing in green. It's saying, oh, you've staged these changes. We know about the changes now. If you want to commit the changes, you need to git commit them. So I'm going to do git commit. And then this -m is for message, I believe. And now I'm going to give the commit a name that describes what I did, so that when I have it on my repository, I can see, you know, if I wanted to look back at my commit history, I can see, oh, like what did this commit do? What did I do here? So I'm just going to say that I implemented the hello world main. That's what I did. So git commit. And now if I do git status, you can see that that file isn't listed anymore. It says that, in fact, it says that your branch is ahead of origin master by 1 commit. That's saying that you have 1 more commit than the GitHub Classroom repository does. And that makes sense. We just added a new commit. If you're unfamiliar with this process of adding and committing, this add you have to first stage changes that you make. And then if you want to commit them to your version control history and like record them, then you do a git commit. Okay, so now I've committed my changes. I can even do, so if I do git log 1 line, it'll give me a short summary of the commits that I have in my branch. So I can do git log one line, and the bottom is the oldest commit and the top is the most recent one. So all of these were from the starter code. These were all the commits from the instructors and setting up the repository. And then this one is the one that we just added. So that's just a nice sanity check to see that, oh, okay, my commit got recorded, my changes got recorded, great. Okay, so now that we have a commit that we've made, let's make the new remote repository that we're going to push to and then submit to Gradescope. So now I'm going to go to GitHub. This is my GitHub page. And if I want to create a new repository, then I can click on this plus in the top right-hand corner. So I click on that, and then I click on new repository. And I get this page, and I'm going to give it the same name as I have locally. So again, I've said this a couple times, but just to be really explicit, yours is probably not named PA1 starter. It's probably something different because you cloned it from the classroom. My repository that I have right here locally was not cloned from the GitHub classroom. So yours will look a little bit different, but you should name this the same as whatever your repository name is. So I'm giving it the same name. And then I'm definitely going to make this a private repository, right? Because I don't want public source code from the class online so that my classmates can see it. That wouldn't be a good idea. So we definitely want this to be a private repository. Okay, so that's it, just those two things. And then I can do create repository. And now I have created a new blank repository, essentially. So it has nothing in it, but it exists and we can push to it. So what you want to pay attention to is this field up here. There's these two options, HTTPS and SSH. You're probably going to want the HTTPS link, especially if you've never used GitHub before or if you're very new to it. I doubt that you have an SSH key set up in your account. So if you do have an SSH key set up with your account, you're more than welcome to use this link if you want. But this is probably the one you want, the HTTPS. So whatever link you have here, so don't use mine, obviously. Whatever yours is here, you want to make note of that and like copy it. I'm going to use SSH version just because that's what I have set up. But you'll probably want to use the other one. So this is the link that I'm going to use to push to this repository. After I've told my local repository about this remote, right? This is the link to this remote repository, this PA1 starter repository on my account. So let's go back to the terminal. One thing that's a pretty nice command, because at least for me, I like to see things visually when there's a lot going on with code and with software and stuff, and I want to know what's happening. So one thing I can do just for peace of mind is I can do git remote -v, and what that will do is it'll tell me about the remotes that this local repository knows about. So currently, I haven't added this one yet. So currently, all it knows about is this remote called origin, and it came from this spot. So I cloned it from the private repository, but your link here will probably look a little bit different. It'll probably be an HTTPS and an HTTPS link, and then right here it'll probably be like PA1 - whatever your username is. But you'll get something here, so don't think it's weird that this looks different. That's expected, but you should have origin and then the link to your GitHub classroom remote here. And so what we're going to do is add a new remote. So this is just one remote. So if I want to add this remote so that my local repository knows about it, I'm going to copy this and go back here. And then what I actually before we add it, I think one thing that's good to do is, so I'm going to rename this origin branch or this origin remote first. So I'm just going to do git rename or git remote rename origin upstream. So all that does is I'm just renaming that remote that I had originally. So I can do git remote v, and then I can see that it successfully got a new name. So I'm just renaming that to upstream so that we can set this new one that's going to be on my account to be named origin. That's all. So now if we want to add this new remote and call it origin, we can do git remote add origin. And then the last thing that goes here is whatever link you are copying from here, you want to paste it here. So yours will look different. It shouldn't look just like this, but so whatever your link is here, just put it here, hit enter. Now if I do git remote v, I can see that I successfully added a new remote. So remember, this upstream one was the one that I originally had and I renamed it. This origin is the one I just now added, right? So this link right here matches this one that I just added. It matches this link that I see here on my new remote repository that I'm creating, or that I created. Okay, cool. So now my local repository knows about this new remote, which is good. So now I want to push all of the commits, push all my code to this new remote. And I can do that doing git push origin master. The origin specifies what remote I'm pushing to, and the master specifies what the branch name is that I'm pushing to. Master is usually like the default branch if you don't have any, so this should be fine. So I'm just going to do git push origin master. I'll hit enter. And if you're using HTTPS, it will probably, it's asking me for my credentials. 1 second. These steps right here, you don't have to worry about. This is for SSHing. So I'm just going to try that again. All I did is basically add my SSH credentials, so it'll push without me having to give my my password. So I'm going to git push again. I'm going to try it again, and it should push. Okay, cool. So it's pushing. It's sending all of my commit history to this new remote. For you, if you're using HTTPS, then you probably will need to provide your GitHub user password. So, okay, so I just pushed the remote. So now if I go back to here, if I refresh this page, I should see that this now has all of the commit history. And it looks like it added stuff, right? So here's all my files. And if I go to commits, not that you need to inspect this, but it's just, you can see it. You can see that all these commits right here from the instructors, these are the ones that were from the starter code, and then this is the one that I just added, which is cool. So even if I, so I'm gonna go back to code, and if I go to, where's hello world, CP, oh, actually no, we don't wanna click on that, right? That's the solution. But you could click on that, right? And then you could see that this hello world does not contain the starter code hello world, right? It should have the changes that you made. Okay, cool. So now we've done a lot of things. In the terminal, what we did is we staged our modifications, we committed our modifications, then we created a new remote repository, and then we pushed to it. So now the last and final step that we want to do is submit to Gradescope. So I'm going to go to Gradescope, and I'm going to submit. So let's do resubmit. And this time, instead of upload, I'm going to click on GitHub. And so it's thinking right now. You might have to do some steps in here to give Gradescope access to your GitHub, just to let you know. I've already given Gradescope access in the past, but there might be something that you have to do to allow it. But okay, so now it looks like it's good to go. It says select a repository, so I'm going to click this drop-down menu, and it looks like a lot of my repositories are showing up from my GitHub account. But the one that I care about is this one at the top. This is the new repository that I just created. So the Macedo22, that's my GitHub username, and then that was the repository name that I just created, right? It matches this. So I'm going to click on this, and then if you recall in here, right, I pushed to master. That was the name of my branch, and I can also double check here that I'm I'm on master is my only branch, right? So the branch is definitely master. It's actually probably that's going to be the only option, right? Yeah, so that's the only option. So I'm going to select master. If you push to a different branch, then select whatever branch you did. I'm going to click on it and I'm going to do upload. And so now it should grab the code from that branch. Okay, cool. So I got the same output. And if I were to go and inspect my code, I could see that I just backed out because I realized that the solution might show up. But if I went to my code, then I could click on the hello world CPP file, and I could see that the code there matches the code from this hello world CPP, as well as the others. But this, I guess, actually didn't show up, so meaning the solution didn't show up. So I think it's okay to click on this. So you can see that it submitted everything from my repository. It didn't submit just the 4 CPP files. And that's okay, because the autograder is just going to care about those 4 CPPs from before. It's going to ignore everything else. Yeah, so that's how you can go about creating a new remote and then using that to submit on Gradescope. If I were to now want to go forward and work on the swap part, I would need to repeat this process of, so let's say I went forward and I edited the swap CPP file and I implemented it, and I'm like, okay, cool. Now I want to add those changes to my repository and then submit to Gradescope again. Then you would have to go through the steps of adding, committing, and pushing again. So those are the 3 things: add, commit, push. Those will let you update your remote. So what I mean is, if I maybe I'll make like a really silly update to swap.cpp. So this is the starter code for swap.cpp. Let's pretend that, let's see, what change do I want to make? I'm going to do nothing. I'm just putting code in here so that it makes a change. So this does nothing. If I were to do git status, now it's telling me, hey, you modified swap.cpp. Let's pretend that I actually implemented or the method that I just implemented, the swap method. Let's pretend that I actually think that I implemented it correctly, and now I want to push those changes to my remote and submit to Gradescope again. Then I would have to go through the same process of adding, committing, and pushing. So what that would mean is I could do git add, and then I could either do git add swap.cpp, or I could do git add dot, which will stage everything in my folder. So I'll just do that because it's shorter. And if I do git status, I can see that it's staged it now because it's green. Also, just to be clear, you don't have to type git status if you're unfamiliar with Git. It's just so you can see the status of your repository. So okay, so I've staged it, and then now I would have to commit. And again, let's pretend that I actually implemented it. So I'll just say implemented swap, I guess. Hit enter. Now, if I do git status, it says that it doesn't show swap anymore. But one interesting thing is that it says your branch is ahead of upstream master by 2 commits. So, and that makes sense, right? So remember that I renamed my original remote to upstream. So for you, upstream, or sorry, yeah, for you, upstream would be the repository that's on the GitHub Classroom. And so it's saying that your current branch here is 2 commits ahead, which makes sense, right? Because I made 1 commit for the hello world, and I made another commit just now for the swap. So that all looks good. So I've added and I've committed, and now I want to, I want to push again. So I'm going to do the same thing, which is git push origin master. And again, for you, you might have to provide your GitHub user or your GitHub password. And then if I go to PA1 starter, and then I'm going to refresh, I can see right here that the most recent commit is implemented swap. And even if I scroll down to swap.cpp, this right here will show me the most recent commit or for that file, which is implemented swap, which makes sense. So if I click on this, my my nonsense one line of code is there. So it's showing me that that the commit was successful. So that's good. Or the push was successful. So that's good. So now if I wanted to resubmit to Gradescope, I could do the same process of, clicking on GitHub and selecting the branch and submitting. I'm not going to do it because we're not going to see new output, right? I did not implement swap correctly. But, provided that you did, when you submitted, then, hopefully you'd see swap is 25 out of 25. And I mean, you don't have to work in these chunks. You can work in whatever chunks you want. You could do all of it and then just do one big commit that has all of your changes, right? And then push it. That's fine too. But just if you are working incrementally, this is how you can go about it. Yeah. So hopefully that helps with how to go about creating a new remote, pushing to it, and then submitting to Gradescope. If you're new to Git, this might seem like a lot of commands and things, and it really is. I remember when I was learning Git, it felt overwhelming, but it's a really, really powerful tool, and it is great in the long run. And like if you think that if you think you'll be working on bigger software projects in the future, it's very widely used and it's really nice. And I'm really glad I was forced to learn it in one of my undergrad classes. So of course you don't have to use Git, but if you want this functionality of being able to submit to Gradescope for this course with GitHub repository, these are the steps that you have to take. So hopefully that helps with that.